Notes 13, page 3. We're going to add subtract rational expressions. So here's our first problem. We need a common denominator to combine these into one term, into one pile. So we have two separate terms. They're not the same type of animal because they're not the same denominator. Now, to get the LCD, we build the LCD from prime factors of all the denominators. So we need factors in our denominators. And check it out. These denominators are monomials. They're one-term animals. We do have factors, okay? So this is kind of the easiest type of problem we could have. Our denominators come to us factored already. So we can use these factors to build our LCD. Now, it is kind of a two-stage process when there's coefficients. And I'm going to keep the coefficients small, not like 60 and 72. First, look at the coefficients, and you should be able to figure this out in your head. What is the LCD between 2 and 3? That's 6. So 6 will be part of the LCD. And now, look at the variable parts of the LCD. So, the variable factors that show up are A's and B's. So I know I will need A's and B's in my LCD. The question is what power? So this is an A to the first, this is an A to the fourth. I'm trying to build something that A to the fourth will divide into evenly. So if I just use A, A is not going to go, A to the fourth is not going to go evenly into A. If I want to make sure I build something that A to the fourth and A go into, I just use the largest exponent, okay? So A to the fourth essentially covers the A to the fourth and it covers the A. Then I look at the B's. I'm trying to build something that both of these will divide into. I need B cubed to divide into it. So I need at least 3 B's. And if I have 3 B's, I got 2 B's. So use the larger exponent when you're building your LCD. So that would be my LCD. We want both denominators to become 6a to the fourth b cubed. Now, before we actually do the next step, notice what we have here, because I keep talking about it. I want this denominator to divide into my LCD. Well, we decided that 6a to the fourth b cubed is the LCD. Here's my original denominator, 6a to the fourth b cubed. If I take that and divide it into my LCD, notice 2 goes into 6 evenly, that's 3. A goes into a to the fourth, that leaves me with a cubed, and the b cubes cancel, so I get a whole number answer, no fraction. It goes in evenly. Also, look at the second denominator. Notice it will divide evenly into my LCD. 6 over 3, that comes out even as 2. The a to the fourths cancel, and b cubed over b squared is 2b. So both of my denominators divide in evenly into my LCD. And that's the smallest expression that this will happen for. That's what I want, least common denominator. And you're going to notice this 3a cubed and 2b are players in the next step. So let's go back over here. We've determined the LCD. The next step is to rewrite each fraction so it has the LCD. And we have to remember, you cannot add top and bottom, numbers to a fraction, top and bottom. That will change the value. You can multiply by 1 in a sneaky way. That's essentially what you're doing. So here's the denominator I have. Here's the denominator I desire. And the best way to think about this is, what factors are missing? Well, I need a 3. And my b cubes are good, but I need 3 more a's. So I need to multiply this by 3a cubed. Well, if I'm going to do that on the bottom, I need to do it on the top. So notice I am multiplying by 1 Multiplication by 1 does not change the value. I do not want to change the value of my fraction. Notice, by the way, we saw that 3a cubed over here. Okay, now let's finish this. This will be 15a cubed over 2 times 3 is 6. A times a to the third is a to the fourth, b cubed. So I got my desired result. I now have a denominator of 6a to the fourth b cubed. Now for this fraction, here's the denominator I have. Here's the denominator I desire. What do I need to multiply this denominator by to bump it up to this? Well, I need a 2 because 3 times 2 is 6. A to the fourths are good, but this has b squared. I need to bump it up to b cubed, so I need to multiply by 2b. And if I'm going to multiply by 2b on the bottom, I'm going to do it on the top because I am multiplying by 1. Doesn't change the value. Notice again, we've seen that 2b from over here. Now, multiply across the numerators and denominators. This numerator is 4b, and the denominator is 6a to the fourth b cubed. All right. Once you have a common denominator, you just add the numerators, and be careful. I do see students go a little crazy right here. You have this many of these things, take away that many of these things. These are not like terms. So your numerator just becomes 15a cubed minus 4b all over 6a to the fourth b cubed. And notice my final answer is all one term, and sometimes we need that. So there are reasons we would want to add starting with 2 terms and condense this down to 1 term. Okay, so the next problem, different in nature. I really kind of jumped sort of difficulty levels, but I kind of started the problem for you. So let's look at this one. Notice there are 2 terms I'm supposed to subtract. I can't throw this into one pile until I have a common denominator. To find the common denominator, I need factors to build my denominators. And factors only in the denominator. I don't need factors in the numerator. I build the LCD from factors of the denominator. Which denominator is already in factored form? This one, the first one. I don't need to mess with that denominator. I do need to factor this one. And first there's a GCF, gives you x squared minus 4. And then there's a difference of 2 squares. You really do need to factor into primes to build your LCD. So this is 3 times x minus 2 times x plus 2. Only now can you build the LCD. So let's look at this. Here are my factors for my 2 denominators. If there are coefficients, you should be able to tell what the LCD is between 5 and 3. That's 15. I will not make those numbers hard. Now, look at your different variable factors. There's x minus 2's and there's x plus 2's. Your LCD has to have all the different variable factors that you see in the denominator. So my LCD will have x minus 2's and x plus 2's. The question is, what power? Well, x minus 2 shows up in both denominators, and the general rule of thumb is use the larger exponent. Because if you pull in x minus 2 squared into your LCD, that will cover x minus 2 to the first. So this needs to be x minus 2 squared. Then the x plus 2 is the only factor, excuse me, the x plus 2 only shows up in this denominator. That's what I was trying to say. And it shows up as x plus 2 to the first. Since that's the only way x plus 2 shows up in either denominator, that's how we take it in the LCD, as x plus 2 to the first. So that mess is my LCD. Okay, so it's really good to write down your LCD off to the side because that helps in the next process. The next step is to take this original fraction and rewrite it so that it has this LCD. Well, I look at my factors. Here's the factors I have. Here's the factors I desire. Which factor's missing? Just the x plus 2. So I'll multiply that top and bottom by x plus 2. Then I look at this fraction. Now I have to write the denominator in because I didn't do that yet. Here's the original fraction. I see the factors that it has. I look over at my LCD. I see the factors it should have. Oh, you know what I forgot? I forgot the 3. That was silly. Sorry about that. I forgot about the 15. So 3 times x plus 2, 3 times x plus 2. Back to this fraction, sorry. Here's the denominator I have. Here's the denominator I desire. Let's not forget the 5. I need to multiply by 5 over 5. And then this is missing one of the x minus 2's. All right. Now, this problem has something different than the other problem didn't have. Since we need to add the numerators, the next step, it's going to have the LCD. I'm going to add the numerators. When you add terms. Well, right now my numerators have factors. I need to distribute in the numerators only. You never add the denominators. You don't need terms in the denominators to add. It would just be a pain to multiply that denominator out. But I do need to add numerators, and when you add, you need terms. So 2 times 3 is 6, so this is really 6x plus 12. So now I have terms in my numerators, times over 15 times x minus 2 quantity squared times x plus 2 minus, okay, this is going to be 5x minus 10 over 15. X minus 2 times x minus 2 is x minus 2 squared times x plus 2. So the denominators are alike. And then this little cloud here, that's to remind you it's this numerator minus this entire numerator. So what do I need to do with that negative? I need to distribute it. So it's 6x plus 12 minus 5x plus 10 all over the LCD, which is 15 times x minus 2 squared times x plus 2. So notice how we don't add the denominators, so we don't need terms. But we are adding the numerators, so we want terms, so we can combine like terms. This is just x plus 22 all over 15 times x minus 2 quantity squared times x plus 2. And then this problem doesn't have one final step that sometimes occurs. That's a 22. You would want to see if your answer reduces, and this numerator is x plus 22. It doesn't factor, so you'd have to see it as a factor of x plus 22. It doesn't cancel with anything, so this fraction does not reduce.